Hello and welcome back to day 2 from the Formlabs User Summit 2021. My name's Liam. I'm from the marketing team here in APAC, based in Singapore. I'll be taking you through our talk today on 3D printing in healthcare. We're joined by 2 speakers today, one from Medairum and another speaker from the National University Centre for Oral Health here in Singapore. Okay. Those 2 speakers are Nero and Roland. Nero is the Business Development Manager at Medairum. Medairum provide 3D printing services for the medical and dental fields in Singapore. They work closely with doctors and hospitals to provide easier access to 3D printing, helping them utilize the benefits of custom patient-specific treatments. He's going to be showing some great use cases of how they've utilized teaching aids, but also they've printed other anatomical models as well. And we're also joined by Roland, who works as a biomedical design technologist at the National University Centre for Oral Health. He also works closely with surgeons, utilizing 3D visual surgical planning, designing surgical guides, splints, and cutting guides for oral and maxillofacial surgery and other surgeries, including surgical splints for orthodontic surgery, intraoral vertical ramus osteomy surgery, mandibular tumor resection, mandibular angle reduction, tooth autotransplantation, and also anatomical models for surgical planning. So, without further ado, let me introduce both of them. Hi guys, apologies Roland, I may have struggled with a few of those phrases, but they're not that easy. So thank you for joining today. I appreciate you taking the time to run through this. I've already seen some of the content you've got, and it looks fascinating. Also, Nero, I think you're going to win the award for the best background. That's not actually a green screen. Nero is in a print farm with I don't know how many printers are there.
We currently have 48 printers at the moment. So yeah. Also, we have the Fuse next door as well. So it's packed with Formlabs equipment at the moment.
Yeah, I did think that was a green screen to start off with.
Everyone does.
Right, I'm just going to hand over the slides here to you now.
All right, cool.
All right, if you want to take it away, and let me know when you want to change over, and I'll hand it over to Roland. In the meantime, I'm just going to remove Roland from there as well. Okay, and take it away, Nero.
Thank you so much, Liam. Again, thanks a lot, Liam, and everyone at Formlabs for actually having us on this webinar. We're really excited to share what we've been doing with Formlabs materials and machines. So without further ado, let me start our presentation. So the agenda for today will be this. I'll do a short introduction on what we as Medairum do, the services that we provide. Shortly afterwards, I'll be joined by Roland, who will share some exciting case studies that he has done with virtual surgical planning and surgical guides. And afterwards, I'll show a collaboration that we've had with the Faculty of Dentistry in Singapore National University that we've been a part of, and how we've used Formlabs materials and resins to actually develop these training models. Finally, I'll close off with some models that we have done for orthopedic applications as well. So I am a part of Medairum, and Medairum is predominantly a service provider in the healthcare space. So we use a lot of Formlabs machines to 3D print anatomical models, convert CT scans to anatomical models. We also provide small-scale manufacturing services for the healthcare industry, as well as dental applications. Also, we do some consulting work in terms of design, as well as if a clinic or a doctor requires to set up his or her own workflow in getting from CT scans to anatomical models, we help with that as well. So just to share with you, so this picture is basically my background. So I'm currently in a print farm that houses 48 printers at the moment. And we are able to run all Formlabs resins and look to provide small scale or small to mid volume manufacturing capabilities to the healthcare space. We have some new additions that we have this year, which we are also excited about, which is the Form 3 BL, as well as the Fuse. So really excited to see some applications launched using these equipment and materials as well. So this is a snapshot of our work so far. We actually started as a company in 2016. We actually started with Form 2. We grew to a bunch of Form 3 machines, and now we have a small print farm running. So as a snapshot, we've been involved in the pandemic last year, printing 4 million COVID swabs, which I'll talk in the next slide. We've also done some anatomical models as well as dental 3D printing. One of the key highlights that I would like to mention in this presentation is a project that we were a part of with in collaboration with NUS, which is the National University of Singapore, NAMIC, which is the National Additive Manufacturing Innovation Center, I2I, Forefront Medical, and of course Formlabs, where we helped to manufacture COVID swabs that were designed by NUS. We used the experience that Formlabs had in the US with their original designs, and we customized it to printing these new designs back here in Singapore, and we were able to really scale up our production from just a few printers to running 66 printers in a clean room facility under ISO 13485 certification. So these are some of the pictures that you actually see which were taken during the manufacturing as well. These printers were running 24/7. They were real great workhorses and really displayed the capabilities of the Form 3 machines of being production units. Also, this gave us a huge experience in 3D printing at that scale. And in a production setting, since the Formlabs machines are quite small, even if one were to basically had problems, we were easily able to replace them very easily without affecting the daily production. So it was a very interesting experience for us and a really good case study to display the use of Formlabs in a manufacturing setting. So apart from swabs, our main area of expertise is basically converting DICOM data, which is your CT scans and your MRI scans, into 3D printed models. So this is a typical workflow that we would go through in order to produce 3D printed parts. So number one would be CT scans or MRI scans get sent to us by a clinic or a doctor. We have a consultation session with them on the region of interest that they would like to print out, as well as the anatomy that they require. Then we will get to work on doing the segmentation for the data to reconstruct the 3D model from the CT images. Once the 3D model is generated, we use our printers to 3D print them, post-process, and get back a physical model, true to scale model of the anatomy to the doctor in time for the surgery. Over the years, usage of 3D printing has been really been popular in the medical application. especially in terms of pre-surgical planning as well as patient and clinical communication. 3D models have also been used in as a teaching or a training aid for undergraduate students or teaching purposes, etc. So in this presentation, we hope to, in this presentation, we hope to basically cover all these different aspects of medical applications with relation to 3D printing. So first, I would like to introduce or call over Mr. Roland Lim, who's from the National University Center for Oral Health, who is kindly going to share some interesting cases that he has done with virtual surgical planning as well as surgical guide. So I would like to invite Roland to essentially share his work. Over to you, Roland.
Okay, can you hear me? Thank you, Nero, for having me. Thank you. Good morning, good afternoon, or good evening to everyone to this Formlabs User Conference Summit. I'm Roland, and I'm here to present to you what I've used 3D printing application in oral maxillofacial surgery, which is quite a mouthful, as Liam has experienced just now. So I'm basically here, as mentioned, Center for Oral Health in Singapore. We are right about this little red dot here in Southeast Asia, and this is somewhere in this building here. I'm level 6. It's my little office here. Okay, this is the agenda. We'll go through very quickly. This is just a very quick, brief introduction. No time into details, but just a brief, concentrating mainly on 3D printing aspect of it. Okay, what is this big word? Is the orthodontic? Orthodontic basically refer to jaw surgery, and there is I posted recently an article on orthodontic capabilities in my workplace. We call it excuse me, National Center for Oral Health, new course for short now, NUCOHS. All right, so you can check out on my LinkedIn. Right. Okay. The first case, oral maxillofacial surgery, or what you call orthodontic jaw surgery, is the bread and butter of what we do here, and it basically is to correct some jaw imbalances here. So if you can just switch on to, let me have a look. Show the audience this part here. So this is a 3D printed model that we have printed by Nero. This is where we call a class 3. So through surgery we can correct that. All right, so also is sometimes the cases whereby we have mandible that is underdeveloped, right? So, or in some cases we have mandible that is slant to one side, asymmetry. All right. Okay, that's it. So coming back to my screen here. Right. So through this, the purpose of this intermediate spline, right, is the first position the maxilla, the upper jaw part of the bone segment. All right. So these are used using the teeth position, the upper and lower teeth position. So after the maxilla part bones is fixed, right, then you use the final splines, right, to position the mandible, the lower jaw part of the bone segment, right? So sorry, the intermediate spline, the one on the left, is printed using Formlabs surgical guide resin, which is autoclavable, biocompatible photopolymer resin, class 1 medical device. Right? As for the final spline, we're using the Formlabs dental LT clear, which is a class 2A medical device material. biocompatible as well. So these little parts you can see, these are the final spleen, and this, if need be, for long-term use, this spleen can stay in the mouth for a couple of weeks if need be. And this is the intermediate spleen that we use. All right, thank you. Okay. Okay, then recently this year, I come up with this, no, not this year, this is 2019, right? Pre-COVID, there was this case whereby the front of the lower jaw has to be segmented, right? So I designed this cutting guide. In this cutting guide, both sides of the mandible, one of the premolar on each side has been taken out to facilitate this this anterior segmental subapical surgery, whereby each of these premolar on each side has been taken, and then the lower part of the cutting guide is to guide the oral surgeon, right, to make a horizontal cut below the canine incisor, right, avoiding the nerve as well as the neighboring teeth. All right. Okay. So this is whereby this is a rendered image of the premolar, one of the premolar taken up, right, and this part of the anterior side will sit nicely with the back part of the mandible. Okay. And this is the 3D printed cutting guide, printed in the Formlabs surgical guide resin and used in the surgery as well. So this surgery was a success, and that my my other oral surgeon with in this case who done this case has written and published a technical journal in the British Journal of Oral and Maxillofacial Surgery, and that's me as well. So it's personally, it's the first time I see my name appearing on a technical journal, so I'm very glad I could make a small contribution in that. Okay, the next slide is a little bit bloody, so rated PG. So if you are not a faint-hearted person, then you might want to close your eyes, right? This is where the surgical guide used in actual surgery. All right. There you go. Okay. So you see the guide is teeth-based and span over this surgical, and this is whereby it's a front view. Right. So this guide was used to guide the oral surgeon where to determine the lower cut point. All right. Okay, this is where I want to salute to all the oral maxillofacial surgeons who have to do this, spending long hours in the surgery, maybe skipping lunch, and and have to do this on a daily basis. Salute to them. Okay, the next case I have a interesting one with a mandible tumor. I designed a cutting guide. This is not the patient. It's just to illustrate to you what is this ameloblastoma. Right, it's a rare non-cancerous tumor that develops in the jaw. Right. So this patient has a tumor, happens to be inside of the mandible. So it's quite a challenge as in the surgery that the oral surgeon will not able to see how much bone is need to take out, how much, right? How much you can't see from the outside, right? So that's where I need to I designed this cutting guide for him, and this is the video how the surgical guide looks like. Okay. Okay, the white part would be how you need to, we call it the template body, which is how much bone graft he needs to get from the hip of the patient, right? The hip bone, right? So this would be the 3D printed template body. This guy is smaller one we use on the hip bone, right, to harvest the amount of bone graft needed to replace what is being taken out. So this is the actual 3D cutting guide, 3D printing cutting guide, printed in Formlabs surgical guide. And this mandible here is printed in the standard clear resin, right? And Nero has helped me put in the blue ink here for illustration, right? Okay. And I have the chance to meet the patient after the surgeon, or a surgeon after the surgery told me the surgery was a success. They thanked me for making and printing, designing the cutting guide. And later on, like a couple of weeks later, during one review, the surgeon, patient asked for me to want to meet me and thank me for designing the cutting guide. So it was really good to know that I make a small contribution to the success of this surgery. So it was really good. It really make my day and adds meaning to my job, right? Thank you. Okay. Next, it will be an interesting project I'm doing with a oral maxillofacial resident who is doing this study. I'm assisting him to what I call 3D stereogrammetry, photogrammetry system of basically a system that will capture the 3D facial image of a person, right? For purpose of like soft tissue simulation that we do, right? Sometimes we need that 3D facial tissue capture for facial soft tissue simulation, right? And in this project image, I make a life-size human replica, of which it has small little tips like this to help us measure the points you need to control between different system, right? System A, system B will measure each system separately. And thanks to Formlabs Singapore for helping us print, we call Sarah, right? So Sarah is quite life-size, too big to print Formlabs 2 or 3. We need to print it on Formlabs 3L. So thanks to Formlabs Singapore and Seiko, that helps us print it in Formlabs standard gray resin, right? So if you want to switch on to the screen here, I want to show this is how big it is, right? So how big, right? So it's like Formlabs now with Formlabs Form 3L. It's like now we have the Hulk, you know, you can print big size part like this. So we're going to use this as a standard and going to take using different 3D photogrammetry system to capture Sarah, and then we measure the different results using this base, using this as a base. Okay, this project is in progress, probably end somewhere next year. All right. So thanks again, Formlabs Singapore. Okay, and we can see that most of these tiny tips we see here is 0.5 mm radius and about 1.5 to 2 mm radius. It survived, you know, the print. We are very happy that it did. All right. Okay. So I've come to my last slide, and as a designer, and those who are designing surgical spleen and cutting guides. I think that is important for 3D printing company like Formlabs to continue to make advances in progress in 3D printers and materials to widen their to make their products even better, the materials even better, and affordable, make it more affordable. Right, keeping the cost low will be good, right? Else the higher cost will be passed on to the consumer or the patient, which is not a good thing. All right. I also want to thank Medairum, a 3D printing service provider, which is just important. I view Medairum as a valued partner, right, who has been delivering a good quality print for the past 3 years, each and every time, making sure that parts are accurate and taking initiative to even to color different parts. Like this part over here, right? Sometimes it can be different color. Right now we can see this is one of the recent cases. So it's important to have a good service provider. So I'm glad I found Medairum and Nero, and we're doing a good job. And that's why I'm doing this, to appreciate not that it's good that we get along and we see a lot of things eye to eye. All right. And I don't have any financial interest in Formlabs or Medairum, but all right. So thanks, Nero, for your good work. Good job. All right. I pass this time back to Nero. Thank you.
All right. Thank you so much, Roland. Thank you for your kind words at the end as well. Yeah, it's been a pleasure working with you and printing for your interesting cases. So thank you so much for trusting us. Okay, coming back into the agenda. So that was 3D printing in oral maxillofacial surgery presented by Roland Lin himself. Next, actually, I would like to touch on a project that we were involved since 2019 with the Faculty of Dentistry here in Singapore, which we were asked to design a wisdom teeth removal trainer. So the training models basically had to fit on existing phantom heads. These are mannequin heads which are used in workshops to train students to develop their surgical skills. So there were certain conditions that were required from these models. The models needed to have a similar tactile feel as to when, as to how they would behave when the surgical procedures were done on them. The internal roots needed to be visible, and of course they needed to fit existing phantom heads that they currently use in workshop. So we started off with cone beam CT scans of patients having these wisdom teeth cases. As you can see in the picture below, there are wisdom teeth which are horizontal, which prove to be painful and need to go and have them removed to alleviate the pain. So we used these scans, and we went through several iterations. We worked very closely with Dr. Raymond Wong of NUS in order to achieve the end results that we currently have in place. So we tested a combination of 3D printing techniques, 3D printing materials, and what we found was a combination of Formlabs dental model and rigid resin had the desired tactile feel for these models. As you can see from the top right-hand corner, we have the internal details such as the nerve running under the teeth as well, which was required. So with Formlabs, initially during the development phase, we used the Form 2, Form 3 machines to do rapid prototyping of the ideas, testing them out quickly, and then doing iterations if required. And this really helped us get through the design phase at a very fast pace in order to arrive at a workable solution. Once a workable model was found, we were able to use the same machines and essentially get into manufacturing mode, where we, as you can see from the pictures below, we printed full builds of these models over days. Of course, since we have many printers, we were able to print them on multiple printers, which meant that we were able to turn around quite large quantities of them in a short time. So this was done, and this is, you can see some images of how they fit on what they call a base model, which then fits on a mannequin head. So in 2019 was when we first trialed this project. We conducted a workshop which involved 54 dental students in the Faculty of Dentistry, where they were asked to practice their surgical skills on removing the wisdom teeth from these models. And here are some of the pictures that you can see of the workshop happening. And below is basically the hole left behind when you remove the teeth from the model as well. A survey was done pre-op and post-op during the workshop to gauge the confidence level of the students before the simulation was done and after the simulation was done. And the orange bars that you see on this chart basically shows the post-simulation confidence level compared to the blue bars, which represent the pre-simulation confidence level of the students. So you can see most students actually reported higher confidence levels after performing their surgery skills on these models compared to before they've actually done that. What was interesting to me through this entire project was basically to learn that the first time a student would actually carry out the surgery was on a live patient. And this, again, is a very scary place to be in, especially for the student. So with the help of 3D printed training models, you can actually help the students fail in a safe space before they actually go out and practice on real patients. Again, improving their skills as well. Something really exciting that we are adding on to this year's iteration of this workshop is basically the gingiva or the gum. As you can, because the previous models we were not able to have the gingiva material on the model. We did experiment with elastic resin as well as flexible resin. However, although we were able to print out nice looking models, unfortunately the material did not behave in the required way, where it was either too weak, so the doctors could not sew it back on together, or it was just not soft enough. So we had to basically do a bit of innovation, and we came up with a technique of overmolding silicon, actual silicon, over these cartridges using 3D printed molds. So right on the top left-hand corner, what you can see here is a 3D printed mold, an iteration of a 3D printed mold. So essentially, the cartridges would be fitted in between them, and a silicon solution would then be poured in and let to cure inside. So we had to go through several iterations of choosing the right silicon material, as well as releasing agents and curing time. And finally, just glad to say that we've arrived at a workable solution that is repeatable. And at the time of this recording, we're excited because tomorrow will be the first workshop that's going to be conducted using these models, having the soft tissue overmolded on them as well. So really excited to see how these models fare and hoping for a good outcome on that. All right, so moving away from the whole maxillofacial and the dental space, we also have some experience in printing models for orthopedic surgery for some local hospitals here in Singapore. And I'll just show you some of the models that we printed. So most of the cases are study models where doctors essentially require the CT scans, which are typically 2D scans, black and white 2D scans, in order for them to convert it into a 3D physical model that they can study prior to their surgery to make the relevant surgical decisions. So this was one of the cases of a patient's hip bone, where the patient's right acetabulum or the hip cup had a defect. You can see from the images on your left-hand side that there was large amounts of scattering and noise that made the viewing of these images very hard, because there were already existing implants in place, metal implants in place, which cause scattering. So the doctor required this scattering to be cleaned up and the bony areas of the patient printed out so he can make some pre-surgical planning on them. So on the right-hand side is the models that we printed. We printed them in Formlabs standard white resin. And we even printed a stand which the model could be mounted on if necessary. This is another case, again, a hip case, where both the femurs had some growth on them. And for the current operation, however, they're only going to focus on the right-hand side of the patient, right-hand hip of the patient. And we were again asked to convert their CT scans into 3D models. These models were printed on the Formlabs machines in white. The femur portion of the model was printed in surgical guide because it had a translucent appearance, as well as it can be autoclaved as well. And something that you might not see is there were screws going inside the femur, which the surgeons need to visualize as well. So yeah, and this was also another study model that we have done. Moving on, a bit more interesting case. This was done for a shoulder fracture. So a CD was given to us of the patient's CT scan of where the patient had undergone trauma on his right shoulder. And as you can see from the images on the left-hand side, they were fragmented into 5 different portions. So what the surgeons really required was be able to 3D print these individual sections separately, so that they will be able to put them back to their original place, what they call a reduction of a fracture, and then shape and fit metal plates that can be prepared prior to the surgery on these models. So that's essentially what they did. So you can see from the models, the pictures of the models shown here, the surgeons basically used these bony fragments, repositioned them, and use metal plates to essentially shape these metal plates, as well as choose the right size of the metal plate prior to the surgery of this patient. And this surgery actually had to be done with a tight deadline. So we really had to turn this model around in, if I'm not mistaken, in 2 days. So Formlabs really helped us get these models out to the surgeon in time. Also, you can see on the picture on the right-hand top corner, we even printed a model in the new draft resin at 200 microns of how the model was, how the shoulder was in its fractured state, where the bony segments were all over the place. So the surgeon also had a physical reference of the fracture, and then he could use the white 3D printed models to reposition them and select and bend the plate. Again, as you can see from the top, the bottom right-hand corner, these plates were bent according to the patient's anatomy and prepared well ahead of the surgery time. So when the surgery came, the patient would need to spend less time in the operating theater as well as less time under anesthesia. For these models, we used rigid 4K because the surface of the model required to be hard in order for these plates to be bent and shaped. And rigid 4K proved to be a very good material for this. Another case where 3D models were used for pre-surgical planning was this case where a patient was undergoing total hip replacement surgery on his left hip cup acetabulum. This model, the surgeon required a full scale pelvis of the patient. The CT scans were segmented, and we printed this in Formlabs white resin. And the model was delivered to the doctor, where the doctor then used it to select the right size of this metal implant by placing it on the 3D printed part, as well as positioning, playing around with the positioning as well as to what was necessary. So for this particular case, actually, a full pelvis is quite big. And definitely does not fit on the Form 3B. So at that time, we did not have the Form 3BL in our house, in our facility. So we essentially had to split into 7 different parts, which were printed in multiple prints. And a total print time of 60 hours was used up in order for this print to happen. And the first thing that we did once we received the 3L was to 3D print a replica of this on the 3L. And this is basically what the times and that we faced with the 3BL. So if you're printing in standard resin, it was taking 48 hours, as well as if you take printing it in draft resin, it would take around less than 20 hours, essentially. The model was prepped in mesh mixer. It was shelled to save material, as well as an internal lattice was generated using mesh mixer as well to add some rigidity to it. And we were able to print it in draft resin in under 20 hours. So it really shows the capability of, or the power of utilizing a combination of draft resin and the 3BL together to really help with printing larger anatomical models that required faster turnaround time in time for surgery. So it really helped, and this was some of the pictures that we have of that print as well, which we're really happy with. We're really excited with the overall quality of the Form 3BL, and excited to do more large-scale models as well. So with that, I have come to the end of the case studies that I have to present to you, and it's been exciting sharing all these models with y'all. So with that, I would like to end this section of the presentation and just hand it back to Liam.
Thank you, Nero. Thank you, Roland. Let's change the screens. Thank you very much. That was fascinating. It's great to see such a broad range of applications. You know, ranging from teaching aids to the actual use of virtual guides, and to finish off there with the large-scale anatomical models, which I know is something which is new in quite recent times, given the introduction of the Form 3L, Form 3BL. So thank you very much. We really appreciate you taking the time to talk to us today.
Thank you
Before
so much.
you leave, I would like to ask just a couple of questions, or one question, if that's okay. Roland, you touched upon it on your talk at the end slightly. If there was one technological development that would further help or advance the benefits of 3D printing in the healthcare space, what would you suggest would be the first? I know you mentioned materials there, but is there a material in particular that you think would be top of the list for you?
Yeah, I think in the aspect of surgery, making cutting guides, the surgical guide resin, which is good. You can autoclave it. It's biocompatible, class 1. But tend to be a little bit soft in certain aspects because, of course, you're dealing with metal blades. But it's good to get feedback from other surgeons on this material and improve on it, Yeah, I would think that's my take.
Okay. Same question for you, Nero. Is there a particular technological development that would help you, software, hardware compatibility, or materials?
Again, I think materials would be one of the key areas that would actually benefit in this space, especially if we are able to produce a material which cuts similar to bone, drills similar to bone, or even in the production of soft tissue, something that's similar to soft tissue, like where surgeons can actually practice their suturing techniques, etc., would really open up applications for this. And also in terms of getting more biocompatible resins in place of different material properties, like what Roland mentioned, something most harder in the case of cutting guides, or even some soft biocompatible materials would also be an interesting addition. Yeah.
Also, may I add that comes to cutting guide, there is a recent request from one of the surgeons that it'd be good to get colors, make it opaque and color, because in the oral cavity they can't see very well if it is translucent. Yeah, there's one other point that I want to make.
Okay, thank you very much. Thank you for that. I think with that, I'll wrap up this talk today. Again, thank you very much, Roland. Thank you, Nero, for your time.
Thank you so much, Luke.
You're welcome.
I look forward to talking to you both in the near future. I'm sure you'll have a lot more applications to share in the coming years as well.
Definitely.
Hopefully some more with the Fuse 1 as well.
Exactly. Yeah, I'm very excited to see how the Fuse 1 comes into play.
Okay.
Kedikan, hands powdery. Thank you so much. Yeah.
You're welcome.
Take care, guys. Thank you.
All right.
Okay, so thank you very much. I hope you enjoyed that talk as much as I did. If you do want to see some more medical content that we have as part of the Formlabs User Summit, please just take the time to look around the platform after this session. There's a lot that's already being presented, either last night, but there's actually a few more sessions to come, a few more APAC sessions in particular as well, that you may also find interesting. So yeah, take the time to have a look around. I'm sure you'll find something that will interest you. Thank you.